Chapter 6 Extra. Complex fractions.
I'm going to talk about complex fractions. The objective is to simplify complex algebraic fractions. So first, let's talk about what a complex fraction is. So you can read that. I'll wait. Just kidding. A complex fraction is a fraction whose numerator or denominator contains one or more fractions. Here's an example. That's a crazy complex fraction. So there's a couple methods to do these complex fractions. You could either simplify the numerator and denominator first, flip then multiply, or multiply the numerator and denominator by the LCD of all the simple fractions. So let's first simplify here. I'm going to do 2/3 minus 1/2. Well, I can multiply this by 3/3, multiply this by 2/2, and I end up with 4/6 minus 3/6, which equals 1/6, and that's over 5/6. This divided by this is flipping fun. It's really 1/6 times 6/5, which becomes 1/5. Okay, that's one method. Another method is you look at all the simple fractions and just multiply the numerator and denominator by the LCD of all those fractions. So I have 3, 2, and 6. The numerator and denominator by the LCD. So it's 6. So I'm going to multiply the top by 6 and the bottom by 6. So I'm going to take this guy, multiply this whole thing by 6, and multiply this part by 6. So I'm multiplying this big fraction by 6/6, which is just 1. And look what happens when I multiply this by 6. What's 2/3 of 6? You know what it is, right? 6 times 2/3. 6 times 2/3. 6/1. It's 4. Minus half of 6, which is 3. Over 6 cancel out. 5, which is 1/5. It's another way to do it. Okay, I'm going to do it with some expressions here. Do you know what I'm saying? Does that make sense? So I multiply the top and the bottom by 6. 2/3 of 6 is 4. Half of 6 is 3. Nice. 5/6 of 6 is 5. Boom. All done. Know what I'm saying? So, two methods. So we're going to do method 1 here. Simplify the numerator and denominator, flip, and then multiply. So let's do that. I need these. I'm going to add these guys first. I want to find a common denominator, which would be AB. Okay? So I'm going to multiply this by A over A, so the denominator is AB, and this by B over B, so the denominator is AB. And I end up with B over BA plus A over BA, which equals A plus B over BA. Now, down here, I have 2A and 2B, so my denominator is going to be 2AB. So, I multiply this guy by B over B, this guy by A over A. And I end up with BB, which is B squared, over 2AB. Here we have AA, which is A squared, over 2AB. Altogether I have B squared minus A squared over 2AB. That's one big fraction here, this fraction over this one, okay? Remember, we're dealing with this fraction. So, I added these guys. Remember, I'm multiplying this fraction by 1. I'm not changing it. This is B over 2A times 1. B over B is 1. This is A over 2B times 1. So, it's still the same fractions. Now, division is flipping fun. So, I flip the second one. I multiply this by the reciprocal of that. So, I end up getting A plus B over BA times 2AB over B squared minus A squared. Well, look at this. But since I'm multiplying these guys, I notice I have an A factor, a B is a factor, A plus B now over B squared minus A squared, but we see a difference of squares here. So I have A plus B over B minus A times B plus A. Well, A plus B and B plus A are the same. Those reduce. I end up with 1 over B minus A.
It's magical.
So these are complex fractions. They take a little bit more time than we're used to. Alright? Here we go, 2W over 3 plus 2. Well, I can make this, I want to have I call this 2 over 1, I guess. And let's add these guys. I'll go 2W over 3. I'll multiply this guy by 3 over 3, and I end up with 2W over 3 plus 6 over 3 equals 2W plus 6 over 3. Okay? What about here? I want 3W is going to be my denominator, so I'll multiply this one by W over W. 3 over 3. This is 1, that's 1. I'm multiplying by 1. And I get 5W squared over 3w minus 15 over 3w, and I get 5w squared minus 15 over 3w, right? So here's my new fraction here, this divided by this. I flip it and multiply, so I get 2w plus 6 over 3 times, flip it, 3w over 5 times w squared minus 3. Is that w squared minus 3? Did I do something wrong here? Let me check this out. 15 times, 45? No. Yeah, that should be 45. 15 times 3 is 45. 45. I know I was missing something there. So I get 5w squared minus 9. There we go. Now, since I'm multiplying, and these guys are going to be all multiplied by each other, notice I have a difference of squares here, so I can rewrite this and I can factor this one. So I'm going to rewrite this whole thing as 2 times w plus 3. Notice I factor 2 out of this factor. Times 3w on the top. 3 here. Times 5, w plus 3, w minus 3. Common factors, w plus 3, 3. That's it, I end up with 2 on the top, and 5, w minus 3 on the bottom, denominator. There we go. Simplified that complex fraction. That was complex. Well, let's try method 2 on the same ones. Method 2 is you find the LCD of all the simple fractions and multiply the numerator and denominator by the LCD. Well, I have A, B, 2A, and 2B, so I need a 2, an A, and a B. So the LCD of all three of these is 2AB. So I'm going to multiply this guy by 2AB over 2AB and get a new fraction. So I'm going to distribute that 2AB, distribute that 2AB. Well, I'm going to end up with 2AB over A, right? 2AB over A, 2AB over B, right? And you can see right away what's going to happen, right? And I get 2a squared b, and you can see if I have a 2ab, you can see things that are going to cancel out here, right? 2ab times b is 2abb over 2a minus 2aab over 2b, and just reduce. Here we go, ready? Watch this. A's are gone, b's are gone, a's are gone, 2's are gone, 2's are gone, b's are gone. I get b squared minus a squared on the bottom now. What do I have here? 2b plus 2a, or 2a plus b. 2a plus b over factor b minus a, b plus a. Those cancel out, I get 2 over b minus a, which is the same answer I got before, right? Oh no, before I had 1 over b minus a, so I must, oh yeah. You know what? Last time I had 1 over b minus a, but I forgot about this too. This guy was supposed to be here. Why don't you guys speak up? Huh? Is it making these sloppy errors all the time. All the time. So here we go. I'm going to do the same guy, one here. I have a 3 and a w, so I'm going to multiply this by 3w. This whole part up here, multiply this by 3w. When I multiply this by 3w, the 3's end up canceling, and I get 6w squared. Right? And when I multiply this by 3w, I get plus 6w over 3w. 3w times 5w over 3. It's going to be, the 3's will cancel, I get 5w squared. And 3w times, this w will cancel out, I get minus 45. And now I end up factoring the 6 and the w at the top. Help with w minus. I feel like I'm doing something weird here right now. Someone's got to help me. Oh yeah, no, the 3's, this ends up being a w, sorry. Oh man. And w squared minus 45. Did I copy this thing right? I don't even know what's going on right now. My brain is toast. Is this right? 2w plus 3 plus 2. Yes. 5w over 3 minus 15 over w. Okay, good. Multiplying by 3w. 3's are gone. 2w squared. Oh. Should have been a 2w squared. That's why. So it should have been a 2w. And that should be a w minus 3. And I factor 5 out of this. I get 5w squared minus 9, which is w plus 3, w minus 3, we already did it, and w minus 3's cancel out. Alright, there we go. Hopefully I have enough time to do this last one. No, I don't, because I'm this foolish man can't add. Alright, so what I do on this one, I'd multiply do it either method, method 2 or method 1. You choose your favorite method. So I can't finish it. Have a nice day.